Hey guys, so welcome back to our interactive notebook. I almost feel a little bit guilty because we've been doing so many videos lately, but this one is going to be very, very important. In our table of contents, we're going to add a new page. So turn to your table of contents, and I'm adding page 18. And page 18 is operations. Remember, operations means add, subtract, multiply, and divide, and we're doing them with rationals. So pause the video here and make sure you get that. Operations with rationals, page 18. Then go to page 18 and get ready to prep your page. And I should have cleared off my desk a little bit before we started, but I think you're okay with it being a little messy. I have this little slip here that I'm going to provide for you that you can paste or glue into your interactive notebook. And today I'm just going to tape it in, just a little piece on top and bottom, but you have access to glue and you can glue it in. This right here will tell you what to do with any kind of problem that you can run across. So let's tackle them one at a time. If we are adding or subtracting in our problem, and the question is in the same form, that means both of the numbers are fractions, both are decimals, or both are integers, this is just going to be a reminder to help you know what to do. So let's first take if they are both fractions. So in our first example 1, maybe I'm adding 1/3 plus 1/2. Well, for fractions, we need to keep the denominator the same. That means these both have to have a common denominator. So I'm going to look at my 3, and I'm going to multiply 3 times 1/2. And that will change this number. 3 times 1 is 3, and 3 times 2 is 6. So 1/2 is equivalent to 3/6. Now I'm going to look at my 2 and change this number into another equivalent fraction here. 2 times 1 is 2, and 2 times 3 is 6. So 1/3 is 2/6, and 1/2 is 3/6. Then when I add them together, I can keep the denominator the same and go 2 plus 3 is 5, and 6 plus, well, I don't add, I just keep the denominator the same. I'm sorry, 5, 6. And you would do the same thing if it was a subtraction problem. If instead of add, this was subtract, you would say 2 minus 3, and then we would have to come down and talk about what we do with integers. Because 2 minus 3 would have been negative 1/6. Let's do that example here. If you have 2/6 minus 3/6, I would have to say that I can't take away 3. So I'm going to have to remember that for a subtraction problem, I need to do the add inverse. If it's not add, I need to do add inverse. So I would keep, flip, and change. Then I would have to remember, do I have same, so I find the sum, or different signs, so I find the difference. Here they're different. So I would put the big number on top, off to the side or on the down low, and I would subtract and keep the sign of the bigger number. So I would get a -1 and keep the denominator. Okay, so moving on. How about if I had decimals? You remember line up the dot, give it all you got? That's just to remind you that if you had, for example, 45/100 plus 3 and 1/10, you just literally line up the dot, lining up the decimal and making sure that all the numbers go. You can fill in zeros if that helps. Keep it, give it all you got, do the work. And how about 3? Say I had -7 minus -3. Well, is it an add problem? If so, move on. If it's not, we got to do the additive inverse. Keep, flip, change. So I'd end up with keeping the -7, flipping that to an add, and changing that -3 to a +3. Now, do I have same signs and find the sum, or different signs and find the difference? They're different. So, big positive, big number on top. Check out the signs. I'm going to subtract, do the work, and check the signs for evidence. Always keep signing the bigger number. So my answer here is -4. Let's look if we were multiplying or dividing. In this fourth example, fractions you multiply straight across. So if I had the fractions 1/3 and 5/8, and I was multiplying, I just go straight across. 1 times 5 is 5. 3 times 8 is 24. I'm done. And that can't be reduced. So if I had a division problem, maybe 1/3 divided by 5/8, then with division, I KFC again or multiply the reciprocal. So I'm going to keep my 1/3. I'm going to flip that to multiply, and then I'm going to change this to the reciprocal. Now I can multiply straight across and get 8/15, which again does not reduce. Let's look at the examples with decimals. First of all, write this down. Calculator. The calculator is your friend here. So with decimals, if you didn't have a calculator, you would ignore the decimals, then count the spaces total behind the decimal, put that number in the answer from left to right. For example, 0.45 times 3.1. Notice I did not line up my decimals. And then I would just multiply normal. Now I had 1, 2, 3 total spaces. So from the right, moving left, I would put in my decimal. If I was going to divide, maybe I had 0.45 divided by 3.1. Then top number goes inside the division box, box top. Bottom number on the outside, we go over 1, up. Remember the over, up? Move this over until you have a whole number. Move that over the same number of spaces and up. And when I multiply this out, my number moves on from there. But you guys remember, use your calculator when it comes to decimals. And finally, for the sixth example here with integers, let me number these. That might help you later. When it comes to the integers, -3 times 4, you're going to use your triangle. Negative times a positive, answer is negative. And 3 times 4 is 12. What if I had -3 divided by -4? Well, I know 3/4 equals 3/4. And if they're both negatives, I know that is 3/4 is 75 cents. But you could have used your calculator and said 3 divided by 4 to get 0.75. But you had a negative times a negative, and that's going to be a positive. I'm sorry, that wasn't visible. Negative times negative is positive. So this would have been a positive 0.75. Finally, here's the toughest part. What if you're giving operations with different forms? Well, let's do it in steps. First, step A, use a calculator to change everything to decimals. Step B, be sure you're performing the operations just one step at a time and use PEMDAS if necessary. And then double check your integer signs. That would be a place that you might be able to find yourself if you're struggling and you're making a mistake. So let's look at example 7. If I had 1 1/2 plus 3.75, and that was a -1 1/2, and then this was in parentheses, and I'm going to divide by 3/8. If it wasn't in parentheses, you would do the division step first, but PEMDAS tells us to do parentheses first. But I've got a mixed number, that means a whole number and a fraction, and a decimal. So I'm going to use my calculator to change everything to decimals. So I know that I'm going to keep my -1, and there's like a ghost decimal there, and I know 1/2, 0.5. So -1 1/2 is like -1.5 plus 3.75 divided by 3/8. Now I'm going to perform the operation one step at a time. Well, I'm going to add these two together and get 2.25. The reason being is that these signs were different. So I know I had to put the big number on top, off to the side or on the down low, as the song says. Signs are different, so to do the work, I'm going to subtract and take the sign of the bigger number. Okay, now, again, I'm ready for this next step. Oh, check integer signs. Good, I had a positive. Now I need to change that to a decimal. So this is still 2.25. 3/8 is, when I use my calculator, 3 divided by 8, I get 0.375. Now I can use my calculator, and 2.25 divided by 0.375, you're not going to believe it, you get the whole number 6. Okay, I hope these notes will help you, and if you have any questions, be sure to ask. Thank you.